Okay, so we should be live.
Okay.
And I'm going to go ahead and so this is part of the Community Build System meeting on February 15th, 2016. I'm going to turn it over to Zishan to talk about the container pipeline and some of his work around registries. So Zishan, take it away.
Yeah. So hello guys, welcome to my talk on the container registries, and this is my information. If anyone wants to contact me, this is how you can get to me. And so let's begin. So here we have our agenda. We're going to cover what is a registry and where the registry is going to fit into the container pipeline, and then we'll follow it up with a simple private registry using Docker registry, which is already there. And then we're going to cover a little bit of pulp or grain, which is basically a community project on Red Hat, and it talks about multiple types of registries which can be shared using pulp and grain combination. Okay, of course. So let's start off. So first off, what is a registry? Uh, when you look at a container, it is basically a packaging mechanism where you package your application with the dependencies which it needs, and that's what it makes up a container, and it's a box, right? So it can be very compare. We can think of it in a very comparative manner with RPM, where RPM is nothing but a package of your softwares, right? So and if you think of it that way, then we can say that the registry is nothing but a YAML repository for uh, your containers, right? So when we look at a YAML repository, we have the repository metadata, which is the index where your uh, Docker client is going to look up whenever.
Can I
Yeah,
interrupt you for a minute? Would you mind putting your presentation into the slideshow mode? I'm getting some feedback that it's a little bit difficult to read on the live stream there.
it is on slideshow right now.
We are seeing the just the LibreOffice, the edit mode.
That's funny. Okay. Now, are you good?
Yeah, that looks great. Thank you.
Cool. Okay, so let's continue. We have so if you look at your containers as RPMs, then we can say that your Docker registry is nothing but location where you can store your containers, and it is basically index, right? So when you do a yum install something, it is going to go to a existing repository somewhere, and it's going to be indexed there. It's going to look up where my packages are, and it's going to download them and it's going to install them. So in a similar way, over here we have, you do a docker pull some image. It is going to go to a Docker registry where it's going to they're going to be pointers to layers of file systems, and it's going to pull all those file systems and it's going to bind them together. Yeah. So this the second point is basically what a Docker registry is defined by uh, the Docker themselves, right? So it's basically a stateless, highly scalable server-side application that stores and lets you distribute Docker images. Okay. Any questions so far?
Looking good. I'll
Cool.
monitor IRC and make sure that any questions get pushed your way.
Okay. So now next thing is where does this registry fit into the pipeline, right? So this is a diagram which Vipalin had in his container pipeline proof of concept. So we have your interface and you have your build delivery, build test delivery cycle, and after everything completes, it goes into a registry, right? So we need what basically happens is when someone uh, like wants to build a container, the container gets built, and then the output of that gets stored into or pushed into a container registry, which we'll be maintaining, and there it's going to be stay in that registry until it is greenlighted by a test system. The test system is going to basically pull this pull this container from from the registry and then run test cases on that stuff. And then once it is greenlighted, it gets pushed into another registry. That's what I've picked up from this diagram. Anyway, so there's going to be two registries: a test registry, and there's going to be a final registry. Usually, the containers will be tagged as test something, test one, version 2, version 3, whatever in the test registry. And when they get pushed, then they get the actual version numbers and even the even latest tag as well. Okay, so first off, we have, so how do we implement a Docker registry, right? So one way that a Docker registry can be implemented is by using the Docker's own registry mechanism, wherein the Docker provides a registry container which you can just pull and up and run, and then we have then we have Docker registry, right? But of course, it is a very it is one container containing everything, and you have it, and it is basically dependent on the main Docker registry anyway. That is your Docker hub. Okay, if you want, and of course it lacks your security stuff. You cannot have login features and all stuff in this unless you go for a Docker trusted registry, which is paid. Okay, still we can just have a look at it how it works and stuff like that. The thing is, the only thing that this provides you is you can set it up as a local host or a domain registry. That's it. Though you will require certificates if you are going for a domain registry. Okay, so this is a typical scenario where a Docker private registry is implemented. You have your Docker private registry, and then you have your developer. He's going to pull his base image from the public registry, and then he's going to build on top of that. Then he's going to push it to your private registry, and then that's going to be in multiple locations depending on his requirement. Okay, so let's see if I can set this up, and the demo ones are with me today. Uh, so let's see. This is how you start a Docker registry. You just run this command and you're up and running. Of course, if you need storage, you need to mount it as well. It's a started container, so anything that goes for a container goes with it, goes for this as well. Oops, sorry. Guess I forgot to download the thing anyway. Anyways,
So while this is going, you mentioned that running the Docker implementation of a registry
yeah,
would require some extra scaffolding around things like security and all that stuff.
yeah.
They don't actually provide like a authentication system or anything like that with it. Is that true?
Yeah, they don't. Uh, if you need it, you need to go for that trusted registry thing, and that is paid.
Okay. Are there are there other implementations that do uh, provide some of those features for us? Do you know of any?
Um, no, I've looked into a few, but most of them don't. Uh, That's what you're looking at Pulp for that reason, because Pulp provides it, but it is a little bit more complicated to set up. Yeah.
Okay. Yeah, because I can imagine that one of the things that we'd be looking into is hooking into our account system in some form. So
Yeah. Oh, that would be good.
so in the IRC chat, um, KB was
Okay.
pointing at asking Dominic if there's a um, Docker registry story in Foreman, and he said that there's a Foreman underscore Docker plugin, which we
Okay.
could probably use. So that might be something good to investigate also.
Yeah, I'll check that out. Oh, this is getting over 92. Okay.
So the Docker registry itself is delivered as a container from, is that just the index.docker.io that you pull that from?
Yeah, there is a registry. Yeah, inside Docker.io, there is a registry container. You just pull it, and then you just do run, and you have it up and running on whichever port you want, and you have it up and running there. Of course, since it's a container, anything that applies for a container applies for it as well. Like you can mount volumes and all that stuff. Yeah, okay, I got that message. You could try that too. Okay. Okay. So that's where it is located, the registry, docker.io.libraries, that's library/registry. I'm sorry, I did this like 10 times, and every time I didn't forget to download this, but this time I forgot to download it.
Is there any, do you know of any best practices related to like actually running a registry related to the resource requirements, like how much memory should we devote to it, or how much storage? I don't know if that's
Yeah,
even,
that's something I'm investigating into.
okay.
Um, I'm definitely investigating into that. Right now, as of the moment, what I'm actually trying to do is get a up and running full-fledged pulp crane setup, and once I have that, then I'll start looking into how much memory requirements this thing needs and stuff like that.
Okay, great.
Okay, so we have the registry running. So let's see. There's a Docker file. So sudo docker. Okay, so we should have this image, but it will not be without any label right now. Let me tag. Um, yeah, so you can see that it is there, but there is no tag or repository name or whatever. So first I need to tag this before I push it. So sudo dot tag. So it's tagged now. So the top push and this name. So push and pull, you need to give the complete. It's like a URL, so you need to give the complete URL of that. So it's now got pushed. So sudo so this is my registry. Let's see if there's the registry. Uh, oops. Yeah, this is what I need. Is yeah, so all from what I found, all of the information about the Docker registry is stored inside a var lib directory. That is, if you go to cd var lib registry, Docker registry version 2, and if you click in here, you have two folders, blob and registries. The content inside this is mostly encrypted, so I'm not able to see the actual content inside them. But what I figured out is blobs is basically where it stores the actual layers, and the repositories is where it stores the links for each and every image. So if you go inside repositories, you will see that the image that I uploaded is available here. Yeah. And yeah, after this it gets encrypted. This is the point to which you can see it, but beyond that it's still getting encrypted. All that is encrypted basically. So I'm trying to see if I can dig deeper into this at some point. If anyone, anyone has questions to you?
Yeah, I think this looks pretty good so far. So, um, one question that I have from sort of the infrastructure perspective is what resources do you need to keep going with your investigation on this stuff? You mentioned that you're working on Pulp and Crane and some of those other things. How can we help?
Yeah, I think I'm looking at setting it up in a cloud or something. Maybe dev cloud or something. We can set it up there, and then we can see if get it
Okay.
up and running at this moment. Yeah. Okay. So let's get back to the presentation. Um, okay, so let's get into Pulp and Crane. Frankly, I don't have too much on this right now, but I'll show you what I have. Okay, so so what exactly is Pulp? So Pulp is basically a community project for server Red Hat, and it is specifically meant to manage repositories. The good thing about Pulp, especially good thing about it, is the fact that it's not restricted just to Docker. You have your Pulp and you have plugins, and if you want to manage atomic trees, you have a plugin for that. If you want to manage Docker images, you have plugins for that. If you want to manage any of these things, you just put a plugin and it starts working. That's what at least that's what it is supposed to be. But of course, it's slightly more complicated than that. Um, Another thing is it has a very well documented test paper. I have been looking into this as well, and it seems pretty clear. Uh, though as of the moment, it is only going to work on RHEL-based systems, CentOS, Fedora, and your normal RHEL and stuff. So Pulp is basically where the registries are going to be hosted. But then, how do people get to those registries? Is through Crane. So Crane is basically a small web app. It doesn't have much of a. It has a very small footprint, and it is meant only for pulls. It's a read-only thing. And what it does is it does not save the actual images, but it redirects it to where the images are saved. And and how does it come to know that? So basically, it uses JSON files, and these JSON files are published by your pulp. Your pulp server is going to publish your JSON files, and the client can consume them. And it can any requests that come to it, it can redirect it directly to where the files are being stored instead of going via pulp. And of course, it's a Flask application. It's a Python application again. Uh, so this is how the pulp crane services work. As you can see, it is a very scalable thing. Like all these components are quite independent of each other, though they have a certain level of independency and a certain level of dependency as well. The independency actually allows you to scale the components as you require, right? So this is how it works. Basically, we have a master slave structure here. Your database is going to be storing the metadata, the create repo index stuff that's going to go onto the MongoDB database. And of course, Cupid, we all know, is a messaging system. And you have your resource manager, the master, and the pulp workers are the slaves. Master slave stuff is somewhat similar to your Kubernetes thing. And of course, storage. There's going to be separate storage. There's a separate storage. There is a separate storage for database and a separate storage for the actual content. And the front ends are there are two front ends, of course. Apache, which is the admin stuff, which can do both push and pull, but it's slightly complicated to work with. And Crane, which is a very simple thing, but it only allows pulls. And a Docker client works through Crane because the Apache doesn't provide Docker API implementation, which Crane does. Okay, so basically, any people who are working with this can only pull existing containers. They cannot push stuff. If they want to push, they have to come from the Apache side. That is the pulp admin. Anything here? Is this structure clear?
Yeah, this is looking great. So on the pulp admin side, is there? I'm assuming that has some sort of access control.
Yeah, it does. It does. It does. It does have access control. You can log in and all that stuff. I'll actually link you to the pulp stuff. There's actually a login thing available for that. Uh, it can even be linked. You can have standard HTTP login, or you can even link it to a Kerberos thing, and you can have the login from there
Ah,
as well.
cool.
It supports everything. Okay. So this is the good points about Pulp or Crane that I found. There's a separation of administration and user interface. Like I said, it has a role-based access. You can support LDAP as well, and master-slave synchronization is available. And then we have your separation of concerns. Like we may not require to, I'm investigating this. If there's a possibility that we may not need to host separate registries, we can have a single registry and then segregate the environments. Yeah. And again, it has a well documented API similar to Docker registry. And yes, event based notifications, Docker registry like this. And read-only stuff. Again, Docker registry lacks this, and of course, it is SOA unlike Docker registry as well. So anything else? So this is as far as I have reached in the pulp investigation part. I was trying to get the demo set up, but it is still a little bit of work left before I can actually have a working demo for this.
Yeah, this looks like yeah, this is great work so far. We definitely appreciate you taking on this investigation. So it looks like you've made some good progress.
Thanks. So any questions?
I don't see any questions on IRC, but we'll definitely post this recording out to the minutes, and then probably get it out to the CentOS Devel list for people to maybe ask questions on the mailing list. So if you could definitely participate in that thread when that happens, that would be great.
Yeah, cool. I'll do that. So I guess thank you for giving this opportunity and stuff. I'm not very good at thank you. Sorry.
Yeah, thank you very much. We're happy to help. Please do let us know from the infrastructure side if there's anything that you need to keep going in your investigations. So
Yeah.
with that, I'll go
Cool.
ahead and close. I'll go ahead and close this recording, and we can send this out to the mailing list. Thanks a lot, Zishan.
Yeah. Yeah. Thanks.
Have a great day.
Same here. Have a great day too.